Okay, so here's the start of the butane lighter experiment. Reading the pre-lab discussion, you'll find out that the goal of this lab is to calculate the molar mass of butane. So what I'm going to do, and I'll kind of talk it through, is I'm going to do the procedure. So at first it says put the lighter into water, and here's my lighter. And I put that in the water, and I'm going to shake the excess water off of there and dry it. Now, the reason why I'm doing this is because when I do this experiment, and if it was dry, the water has mass, and if it's in these little crevices and stuff and I can't get it out, that would throw off the weight of my experiment. So now that I've done that, I've dried it off pretty good, I'm going to put it on the balance. And we can record our balance. And that number is kind of hard to see there. I'll maybe scoot it forward. That is not a 1, it is a 7. So this pre-mass of the lighter is 20.76. So you can see that I've recorded that down in the pre-mass of the lighter. Now, going on to number 2, it says filled to the top a 100 milliliter graduated cylinder, and I can do that simply by filling it up here and getting the water in there. Now, the key or the important part, if you see here, is there's no air bubbles in the top. We don't want any air bubbles because we want just the gas of butane. Now, I am going to take my butane lighter and put it right underneath the opening and fill this up to 90 to 97. So let me do that real quick. Now hopefully you can see that the gas, move over here, is filling this graduated cylinder. This is what we call water displacement. So it is pushing, the gas is going up, pushing the water out through the bottom. And again, we want to get to about 90, 97. We don't want to go over 100 because the graduated cylinder only goes up to 100. So I'm getting close here. And I'm going about 90, 95. I'm going to stop right there. So I've stopped, and you can kind of see, if I lift it up a little bit, you can see where that water level is. It's hard to read from here. I'll put the camera a little bit closer. You can see that volume. So on this one, I'm going to help you read it. We're going to get close down here. We're looking, this is right at 94 milliliters. So I'm going to hold this right here where it says volume of gas collected in milliliters. We collected 94 milliliters. 94.0, we're going to be exact. Now, we got to find the post mass of the lighter. So here's my lighter, and again, I'm going to use a paper towel to gently get all the water off. And now put that back on the balance. Get all that water off there. And we see the mass has gone down. In this case, you can see that it is 20.52. So we have the mass before and the mass after. So minusing these two will give you the mass of butane. You can do that on your own. Now, the other things we need to find out is the temperature of the water. So I have a thermometer. It is set right now at 20.4, but let's put it in the water and see what it goes to. I'm going to just let it sit there for a second. And as it sits in there for a second, let's talk about the other things. Barometric pressure. Now here is what we're going to look up, and we are going to assume at any time that you're doing this lab would also be the pressure right now. So I would say go on your phone and look for the barometric pressure. It might not give it to you in torr. You may have to convert. Now remember, torr and millimeters of mercury are the same thing. Now, that gives us enough time. The temperature should be able to be recorded, so let's look at the temperature. And we get a temperature of 20.3 degrees Celsius. So we can put our 20.3 degrees Celsius. And now, with that number, we can find the vapor pressure of the water. So let's remember 20.3 and go to our back. 20.5. Let's go a little bit in the difference about that, and let's say that is about 18 millimeters of mercury or torr. So we can put that right there. Now, once you've found the barometric pressure in millimeters of mercury, you can minus those two to find the pressure of just the gas using Dalton's law. Now, we need to do this 3 times. For the sake of arguments, I am going to put in some data that what we might have. So, looking at this, our post mass of the lighter was 20.52. That's about where we would start. So we can start at 20.52. Now, I'm going to do the same thing really quick. The only numbers that are going to change are your post mass and your volume of gas, and I'll tell you what that is. The temperature will stay the same, and the water pressure will stay the same, so they can stay the same. So here we go. Let's do round 2 or trial number 2. But before we do that, let's have a little bit of fun with butane. You know that butane, a lighter, catches on fire. So here's what I'm going to do. I'm going to put this rubber stopper in the bottom, collect it, or hold it right there. I'm going to have to do this carefully with one hand. I'm going to take it out real quickly, undo the top, light a match, and woo, look at that. We caught on fire. Woohoo! So that's a little fun that we can have here, and put that in the water and finish it up. Now, let's do our second trial. So again, what I want to do is make sure that there are no air bubbles in here and fill it up again. So here we go. And we're getting pretty close. Stop about there. Perfect. Do the same thing we did before. hold that there. Get all the water off. Use a paper towel to get it all nice and dry. Shake it out a little bit. Put it on our balance, and we see that our mass again did decrease to 20.23. And let's look at our volume of gas we have. Try to zoom us in a little bit. Now if we look real close, you can kind of see that water level there. Again, I'll give you a good number. This is 93.0. So 93.0 is our number of milliliters. So we would do this a third time, but because you're online, we're just going to do 2 trials. So from those 2 trials, you can be able to calculate. Not a lot of room here, but to show your work. Here we can find out what the expected value or what we know to get. And then to find our percent error, what the actual value is, the math, minus our experimental, divided by our accepted. And then you can answer those questions. Now don't forget about the back page. All right, good luck.